Hi everybody, I'm here to give you a little intro to shapes called conic sections. So the first shape should be familiar to you, and that is a parabola. So notice we have 4 different types of parabola. I actually see them as 2 different types, split right here. The first type, notice that they open up and down. We should already know the equation of that. I'm going to write it in vertex form. So y equals a times the quantity x minus h squared plus k. And remember that hk is a point that represents the vertex. So here in conic sections, we're also going to talk about sideways parabolas. And it's actually really easy to write the equation of a sideways parabola. All we're going to do is start it off with x equals instead of y equals. We're going to keep that a value, and in the parentheses here, instead of having x minus, I'm going to have y minus. So I kind of switch the x and y, but I'm actually going to switch the vertex here as well. The k is really the y value of that vertex, so I'm going to keep it with the y, and the h is really the x value of the vertex. I'm going to keep it out here. So that is how we would write the equation of a sideways parabola. Let's move on to a new conic section. So here we are with the circle. So take a look at the circle. We know that a circle has a center and it has a radius. So the equation of a circle is going to have to show both of those pieces of information. And here it is. We're going to have x minus h all squared plus y minus k all squared, and that's going to equal r, or in other words, the radius squared. So the hk is really the center of the circle, not the vertex, right? A circle doesn't really have a vertex. So hk is our center, and r is the radius. And we're going to practice these as we work through them, but until we get to the back, you're not going to see this done as an example yet. So let's do the last type of conic section that we're going to do. We're actually not going to do all of them. So we're going to finish it up with ellipses. And an ellipse is really just an elongated circle. And the ellipse, notice, has an axis of symmetry right there through the middle, but we also have one right here. And right where they cross, we're going to call that the center of the ellipse, just like we have the center of a circle. Now notice that other differences between the circle and ellipse would be that the radius isn't the same as you trace the ellipse. It changes, right? You can tell on this one here that the radius is longer on this side than it is on this side. And then on this ellipse, if I draw this one in, you'll notice that this radius is longer than this radius. So we're going to reflect that in the equation for the ellipse. It looks very similar to the circle, so I'm going to start it off. X minus h all squared plus y minus k all squared. But instead of having it equal to the radius squared, since we don't have the same radius everywhere, we're actually going to divide by the 2 different radii that we just pointed out. So I'm going to call this distance here A and this distance here B. Notice that A is horizontal and B is vertical. So I'm going to keep A connected with the x-axis. So I'm going to put it right under here, but I'm going to square it. And B, I'm going to keep that connected with our y values, so I'm going to divide here by b squared. And if I do that, our equation will equal 1. So let me just kind of summarize what we did there. HK is still the center, like in the circle, but A is a distance, just like a radius is a distance, from the center, I'm going to say, to a horizontal vertex. I'm going to call this a vertex right here. And this is going to be, I'm going to call this a vertical vertex. So B equals the distance from the center to one of the vertical vertices. And there would be our equation of an ellipse. Let's see this in action. So look at that. It looks like we have a bear or a mouse. It has a head and it has ears and it has a mouth. But I didn't give it eyes and a nose. That's actually going to be something that you do on your own. You can be a little creative with that. But just to kind of get in the spirit of the project that we're going to do, we are going to try and write down the equations of this picture. And that's because in the project, you're going to pick your own picture and then have to come up with the equations and graph it on the computer. It's going to be really fun, actually, especially because you get to choose your own thing. So here's some practice. So we have the head of this, I'm going to call it a bear. Notice that the head is actually an ellipse, and its center is at 0, 0. That's excellent. I'm going to start writing the equation down for this ellipse. Since its center is at 0, 0, I don't have to worry about that hk value. So I'm just going to leave it as h squared plus y squared. But now we have to worry about this distance here. Remember, that was the a value. Here that's 4. So I'm going to divide the x squared by 4 squared. In other words, 16. And then I have to worry about this radius right here, which is 6. That's going to be our b value, so I'm going to divide y squared by 6 squared, so 36. And then that's going to equal 1. And that's the equation of the head. Let's look at the left ear. The left ear happens to be a circle, because look, there's the center. That radius is the same as this radius. I think that's a 1. So let's write the equation of the left ear. The center of the ear is at -3, 5. So there is our h and there is our k. Let's fill that in. X minus -3 really is written as x plus 3 squared plus y minus k, which is 5 squared, equals the radius squared. Well, the radius here is 1. So 1 squared is 1. Now look at our picture. It's nice and symmetrical, right? If I were to fold this bear right along this y-axis, I think these ears would match up. So these ears have a lot in common. They definitely have the same radius, and their center, notice that they both are a y value of 5, but their x values are opposites. So I'm just going to make it the opposite of what this was here. So that would be x minus 3 squared plus y minus 5 squared equals 1. Look how similar those circle equations are. Remember, the only thing really different about them was that x value. Alright, now to finish it up, we have a smile right down here. What shape does that look like? That's right, it's a parabola. So the equation of a parabola that opens up starts with y. So we have y equals, its vertex is right here at 0, -4. So I'm going to say that that is x squared minus 4. And its a value, remember its a value is how much you go up if you go over 1. So that's exactly what I'm going to test right now. If I go over 1, how much do I have to go up to get there? Up only 1. So if I wanted to, I could fill in this 1, but it doesn't have to be there either. And notice that the parabola doesn't have arrows on it. So I'm going to say that the domain of this parabola is only from this point to this point. What are those x values? This point has an x value of -1. This point has an x value of 1. So I'm going to say the domain is from -1 to 1. Great. It is now your turn to put on some circular eyes and an elliptical nose and write down the equation. And then we're going to be in the computer lab and you're going to test them out. So we'll see you then.